Hello, and welcome to another Into the Terminal. Today, we're going to be talking about Linux benchmarking. Everyone's favorite topic, right, Nate?
So exciting. All
Now,
the
Nate,
excitement. It's going to be so wonderful, and everyone's going to be excited.
so you told me before the show that this was like not your jam.
Yeah, well, mainly because I only really cared about benchmarking when things were on fire. And then it's like, go to the Googles, try to learn something to figure out what it is that's currently a problem, fix the problem, move on with your life. I didn't do any like active monitoring of benchmarks, which maybe I should have. And then those things wouldn't have been on fire.
Yeah, maybe. So why don't we jump in the terminal and we'll show you a simple benchmarking suite to get started with.
All right. You have two. Which one do you want?
Oh, how about I'll just toggle it on. How about that?
You can do that.
Look at me. Look at me. All right. So I've installed extra packages for Enterprise Linux repo and DNF list CIS Bench. So they have this. They actually have a couple different benchmarking, either harnesses or complete benchmarking software packages in extra packages for Enterprise Linux. But we're going to start off with this one called CIS Bench because it's fairly straightforward and easy to run. The others can be somewhat more challenging. All right, so I've already installed it from extra packages for Enterprise Linux. And it has a whole bunch of basic system benchmarks that you can use. Like we can use sysbench, CPU run, and it's going to start up a CPU benchmark where it's like using prime numbers, and it will run over a default time period of 10 seconds, right? That's why you see under the outputs there, the total time is roughly 10 seconds. And then it gives you a little bit of details on what it's looking at. All right, so the thing about benchmarks, though, is that what you're doing is you're trying to gauge the maximum capability of your machine. And we'll talk a little bit more about this in the deeper dive. But you're doing that so that you can compare the maximum capability of the machine to the maximum capability of something else. So why don't we do the same benchmark on another box right here, and we'll do a sys, oops, if I log in, sysbench CPU run. Right, so it's running the exact
when it's least useful, right?
Right. So it's doing the same exact test, right? Prime numbers ran for the same period, 10 seconds by default.
Yep.
But we get the total number of events on this machine is 22,690. Whereas if we flip back over to my first machine, let's try this again. There we go. The total number of events was 9,155, right? Roughly half of the number of CPU events. And so by looking at these two results, we could say, oh, well, the second machine was better than this machine, right? Because its numbers were higher.
Right.
All right. So a couple of things, and we'll talk about this in the deeper dive. How long does it run? What else is happening on the machine? Are the two machines actually equal in certain ways? So we'll take a look at those in the deeper dive. But so here you go, a basic CPU benchmark. All right, so let me run a couple others since we're here. So we can also do a sysbench memory run. So it's going to do a test where it's writing a gig of RAM, and it's just writing into that gig of RAM, and it'll basically give me the same format, right? The total time is 10 seconds because that's the default that sysbench runs for. And here's the number of events that happened during there, right? So about 45 million events happened during that 10 seconds. All right, but when we look at the other machine, it's doing the exact same test. And instead of 45 million events, let's see what comes out the other side. That one is 51 million events.
Yeah.
So again, more is better. More events is better on this benchmark. So this is clearly a better system. All right, the last one is a little goofy, and I'm only going to do it on one of the two machines because it requires a little bit more overhead of like me typing and doing stuff. So the last one is going to be, and I lost my episode guide, Nate. No.
How could you do that? That's such an important piece of the show.
It is.
Here, I will send you the link to it.
No, I got it.
Okay.
I had to look at my history. And you'll see in a second why I want to have access to my episode guide, because I'm going to be doing some copying and pasting.
Yeah, this is a long one. I can tell.
Yeah. All right. Paste. So this one, we're going to do a file IO benchmark. And so file IO benchmarks for CIS Bench actually require a bunch of additional parameters. And we're going to do one thing first, which is instead of just running the benchmark, we actually need to do a prepare step. So what we're doing is we're making a file size of 2 gig. And I told it I wanted to make one file of 2 gig. So it's going to go ahead and like plop that file down. And then it's going to do stuff on this file in our benchmark run. And this is where the command gets really gnarly. All right. Whoop. Let's try that again. There we go. All right. So some of the parameters I pulled from my prep step, right? I wanted a 2 gig file size. I wanted only one file, but then there's some additional things. So file IO mode, async. Most of the time we're doing file IO on a Linux system, it's done asynchronously. That's the normal way of doing file IO. And so when I'm doing my benchmark testing, I am telling it to use asynchronous file IO, which is normal. You could also do synchronous file IO, which would cause it to skip buffering in RAM and would just like actually try to bang stuff onto the disk drive. File fsync frequency. So I'm telling it 0, meaning don't bother with this. But you could say every so often or however many syncs you want to do against the file, which is again going to like flush stuff from memory to the disk drive. And then the file test mode, I'm doing sequential reads, right? So I have this 2 gig file, and we're just going to like start at the beginning of the file and read it all the way through to the end. And then the file block size, this is like how much of the file I should request at a time. And this is going to require you to know some about your backend disk IO configuration because you want to choose the actual like block size for your files that are really being used by your file system. All right, then run. We're going to run this this benchmark. All right, so again, it is going to run in 10 seconds. It's going to do a sequential read on one file that's 2 gig in size, and it's actually going to do that a couple times. And so we can see the number of events, that's the reads that it was able to push through on this 2 gig file. And we could see the throughput of how many reads or writes I got per second or megabytes per second. So what I'm doing is I'm getting back like, what does my disk subsystem performance look like for this specific type of workload? All right, so that's kind of an introduction to doing some benchmarking using the CIS Bench benchmark tool. There are a bunch of other benchmark tools out there, and we'll mention some of them in the deeper dive. Also, we'll talk about interpreting other people's benchmarks. So I was telling Nate before the show that I watched a Jeff Geerling video where he was basically comparing some Raspberry Pis that he is very fond of to a set of frameworks that have AMD processors and wanted to see like which one was better at different things. And so he has a bunch of benchmarks that he prefers to use for performing that work. There's another very well-known internet site called Phoronix, where he does a ton of benchmarking stuff, and we'll show some of the content that he's produced for RHEL there, and then how to interpret and read those. So don't forget to drop a like, and if you're interested in our content, don't forget to subscribe. Nate, anything I missed for the deeper dive?
No, I think you touched on it all. We will dive deeply in just a moment.
Swooshy swoosh.
Swooshy swoosh.
All right. So now is the time in the show where we'll actually like pay attention to chat and answer questions. And if you're a deferred viewer, please feel free to drop a comment, and Nate and I will get back to you on that.
What do you mean? I'm paying attention to chat.
Well, I mean, yes, but like we haven't been reading into the show.
Oh, okay. Okay.
All right. So benchmarks. Nate, before we start on that, any questions from the chat on what we covered in our critical path?
There was sort of two related questions from, I think they were both from Shantanu. The first was a question around whether you could use the command line assistant to not just get, but compare this data. And I think the answer is probably maybe, but it's the command line assistant doesn't intrinsically know about what your system is doing and how it's operating, but you can feed data into it through command line redirection. But even that is limited, right? There's only a certain length, a certain amount of data you can put in. I don't know how you would give it more than one result and ask it to compare them or anything. So I think the answer is probably, at least for now, no. You can't really get like really in-depth analysis out of the command line assistant when you're talking about benchmarking. You have any opinions on that one, Scott?
And I would go a step further and just say no, because command line assistant is trained on several things. And one of those things is not extra packages for enterprise Linux or the
Right.
data that's and software that's provided there. So I
Right.
would guess that command line assistant would probably not even know about CIS Bench.
Right.
And RHEL ships with, most of the benchmarking suites are not going to be something that natively comes with RHEL. It's something you have to get extra.
Yeah, there's a handful that come, but yeah. And then the follow-on question was, if the answer to that was no, which it is no, is there a tool that lets you do that, that'll let you feed in the data and compare? I don't know if there's a specific LLM-backed tool, if that's where the question is leading, although you could probably leverage something like, ChatGPT or something like that to do it. I just haven't tried it, so I have no idea what kind of results you're going to get.
Yeah, so I happen to have the privilege of talking to the Red Hat performance engineering team every couple of weeks. And this is a team at Red Hat that like literally does benchmarking all the time as their job. They work pretty hardcore with the kernel and a bunch of other subsystem teams within Red Hat. And essentially they like generate this data. They generate the data and then put it into something like a Google Sheet so that they can then run analysis and graphs and like other things based off of it. I guess you could use other tools like ChatGPT to do those data visualizations for you. But essentially it's like running the suite, getting the data, crunching the data down into like a, I don't know, CSV file or something else, and then importing it into a tool, cutting out some outliers, and then doing some graphics. Right. That's usually how this works. Is you try to like looking at pages of numbers is probably not going to help you too much. But
Yeah,
if you
while
look
it
at graphics,
certainly gives you the data, a graph will definitely help you visualize said data.
yeah. So why don't we like talk a little bit about what we're actually trying to accomplish with benchmarking? So the idea of benchmarking is that we're going to do something on the machine that tests its maximum throughput on some task.
Right.
Right. In the deeper dive, we did CPU, memory, and file I/O. And each of those ran as a separate test, and they each had a different like model for doing loading of the machine to be able to measure that loading of the machine to produce results. And so, for example, the file IO, right? It created a file that was the size that I told it. And then it did an activity, which in this case was sequential reads. And it just did that on the file so that it could then measure the maximum throughput of reads that it was able to get during the time period that we were sampling. All right. I would say that benchmarks generally are trying to produce what is the best possible utilization that your machine could ever be possible of making. Right. So like, I wouldn't expect on a normally running machine that it's doing that level of disk IO.
Right.
Right. Because how many workloads do I have that actually just like pound away at sequential reads on the disk?
I'd argue that if it is doing that level of workload, you have underspec your machine.
Yeah, fair. And so really what you're doing with benchmarking is saying, all right, what are the theoretical maximums for my machine? And so when I'm doing things like normal workload stuff,
Right.
You can look at things like the reads and writes per second reported through tools like IOStat,
Right.
and then compare that with your benchmark to see whether you're like approaching that maximum limit that you expect to be capable versus what your system is normally kind of doing.
Right. And
And so,
to my point earlier, right, where I said I usually only cared about system performance when things were on fire. I didn't have benchmarks to go from. So it was more like, okay, I'm getting alerts on a thing. I have a hunch that it's this thing that's the bottleneck. Let's do some tests. The tests show me numbers. I have nothing to compare the numbers to. So it's
right.
more like instinct. That feels high, that feels low, that kind of thing, right? Whereas if you have the benchmark, or even if you had that data from when things were working properly, right? Like if you just had run the same tests when things were working properly, like maybe the day you put the thing into production, right? You'd have something to compare to, and it would be a lot less of a shot in the dark.
Yeah. And Nate, you know what I'm going to say about feelings. What aren't feelings? They are not
They're not data backed.
facts. They're
Yeah,
not
they're not
facts.
facts. Yeah.
Right. And so that's where like, oh, man, it drives me crazy, right? This feels slow. Feels. You
Right.
don't want to tell me what it is doing that's slow.
It feels slow. Yeah, right. Although, I mean, there's a surprising amount of systems administration that comes down to gut experience, right?
Yes.
But
Fair.
usually that needs to lead into finding facts. So, yes.
Yeah. So as you're doing these measurements and you're kind of getting these theoretical maximums, there's also some things you need to consider. Like I was showing you those two machines and we were comparing and contrasting them, and we could see that the first machine that I was running stuff on was less good at the benchmarks than the second machine.
Right.
Except we only compared one run on each of 10 seconds. That is a very small window of data to capture.
Yeah.
Right. So when, for example, the Red Hat performance engineering team runs benchmarks, they run many passes of data collection, not just one. Because by collecting a whole bunch of passes of data, you can actually identify like outliers that don't seem the same as all the others. Right. So, for example, what if I'm running the benchmark on this machine and it recently booted up, and it just so happens that that's the time that the machine also decides to do the update DB to update all the man page keyword searching stuff.
Right.
Right. Or it's doing temp watch and it's actually like crunching through to see if there's temporary files it can delete.
Or,
Well,
right then it got 10,000 web requests that, were out of the ordinary, right? And all of a sudden it's chunking away on all that stuff while you're trying to run your performance test.
yeah. So I would also say you don't want to run benchmarks on in production systems.
True. I'm just giving examples of things that could happen, right? And that's a great caveat that we did not touch on yet, is that running these things obviously taxes your system. And if you run on a system that's expected to be in production, then you will notice it, right? How much you notice it and how much your customers or perhaps your boss notices it is up to be seen. So
Yeah. And so what you want to do, like, let's say one of these things happens where there's a spurious system event that causes the benchmark to perform much lower than the other runs of that benchmark. So in like data science world, you would look at that and be like, oh, this one's way off of all these others that are clustered down here. I'm going to take this one, I'm going to throw it away because there was something weird that must have happened during the running of that benchmark, right? So when you're putting this all together, you're running a bunch of different runs of the data, and then you're looking at the data and throwing away ones that are drastically different than the others. And then you could use tools like averaging and other things to kind of get down to what a good representation of the data that you're trying to get out is, right? So you can come down to one number, or you can look at them in series and just kind of see how much fluctuation there is across them and figure out that fluctuation. And you have a pretty good idea of what your system throughput should be on that benchmark. So that's one thing. The other thing is like 10 seconds, like that's not a lot of time, but maybe that is the amount of time for like a file IO, because maybe that's like roughly how long it should take, right? Whereas if you're just like doing 4 hours of file IO, is that a realistic test of what you're wanting to capture for data from a machine? So using some of the thoughts on like what you're looking at. I specifically chose one file 2 gig because I do a lot with things like ISOs, which are those like bigger files. Maybe your application does a ton with small files, and instead of saying one file 2 gig, it should be 87,000 files of 1 gig.
2K.
Right.
Yeah.
So you want to try and get your benchmark settings to mirror your expected workload settings.
Right.
Yeah. So that's, I think, some kind of overall rules of thumb for using benchmarks and benchmark tools. Any thoughts?
No, you're doing great, Scott.
Keep going. Talking about the numbers. All right. So we talked about the different types of benchmarks. Let's talk about maybe some other alternatives. So I mentioned in the critical path, I was watching this video recently where Jeff Geerling was comparing a pile of Raspberry Pis that he loves working with a bunch of frameworks using AMD processors. And so he ran a couple of benchmarks against them to then say, is this better or is this better? And ultimately, that's how most people use benchmarks, right? They want to compare two things. Generally, the things are similar, right? So in that example, we're comparing two different CPUs. And so you would use, because you're comparing CPUs, you wouldn't want to do things like file IO benchmarking. You'd want to use CPU benchmarking to compare two CPUs to one another.
Yeah, right.
And so there's different benchmarks that you can choose. In that video, Geerling used one called LinPack, which is like a whole bunch of math. It just does math, which is like a great way to exercise your CPU because computers like doing math. And you can figure out how much maths they can do.
If he was using the newer boards from Framework, those have those AMD AI chipsets. So he may have been intentionally hitting it with those to try to test the math processing.
Maybe. I think it was more just like, because the results that he showed were how many flops he was able to do. Right. And that's how many compute activities that each CPU is able to do. And so one that is able to do more compute activities is better for that benchmark. Now, the reality is, like, in production, is he going to have his CPUs doing nothing but maths? Probably not.
Depends what you're using it for, right?
Yeah. I mean, if you're a research institution and you're doing a lot of, I don't know, cryptographic analysis of a thing, right? Cryptography is also maths. So maybe that is like an important.
You don't know. Maybe he's building a crypto miner farm.
He was doing distributed AI, but like, yeah,
Okay.
Fair enough. So yeah, like picking the right benchmark to test the thing you want to test, and then you want to compare two things, everything else being as equal as possible, right? And
Right.
so that leads me to like my next thing. Nate, I tested those two machines. Are they the same?
They are not the same. I mean, I knowing what I know about what you deployed them on, they are absolutely not the same because one of them is a virtual machine on your laptop and the other is a cloud instance. So they're gonna. I would have expected vastly different results from the two machines just because they're so different.
So there's a difference in architecture between the two machines, right? But also, like, at what point did I make sure that they had the same CPU cores available,
Exactly. Right.
right? Or if I'm testing memory, like, do they have similar memory available to them?
Right.
File IO, I absolutely expect to be very different between them because
Yeah.
one is using cloud storage and the other one is using local hypervisor based storage.
Right.
Um, and so, why might you do a comparison like this? Maybe you're looking at cloudifying your on premises running machines and you're sending them somewhere else.
Yep.
Cool. That's a perfectly businessy thing to want to do. But you also need to know like how big of instances do I need so I can get similar performance from my local system to the cloud system. And it might be that like you need to pick an instance with slightly larger amounts of CPUs to compare because it's doing more pass through or it's running on different hypervisors at the cloud provider or using different chipsets at the cloud provider. But you wouldn't know that unless you did a little bit of benchmarking to compare the two things so you could make sure that you were getting similar compute performance out of your new environment compared with your existing environment. You might also want to do things like if this is a database system, well, databases do file IO. So maybe you need to test your database against or your database workload against both places. So maybe there's some options the cloud provider can provide for faster storage, as an example, for you to attach to your instance, because that will get you the throughput that you need to match what you're migrating off of. So yeah, make sure you're comparing apples to apples. Um,
Or
Nate, you want to hear?
I guess honestly, you don't have to be comparing apples to apples. You're comparing one thing to the other to evaluate a move, right? The whole reason you'd be doing that is because you know they're not the same thing, and you want to see if the destination thing is up to the task or not, right?
Well, yes. So you're comparing two different platforms, but you're comparing them using the same comparisons, right? So you would
Sure.
use like
Right.
the same benchmarking tools on both so that you're comparing two identical things and you know what is different beyond that because that's what's giving you your evaluation.
Right. Right.
So do you want to hear a benchmarking horror story, Nate?
I think everybody loves a good horror story.
So benchmarking in the 1990s and early 2000s was like stupid.
Yeah.
Companies used benchmarking in their marketing materials all the time. And it became so ridiculous that it basically became useless. So I remember reading a thing for a new storage array that a company was producing. And when someone produces a benchmark and they're using it in like their advertising or something else, a best practice is you describe the environment in which the benchmark was run, right? Because that way
Right.
somebody can read and like evaluate what it is.
Or they can
So
even
there were,
redo it, right?
yeah, they
The
could potentially try to reproduce it.
the important thing about tests is that they are repeatable, right?
Wow, that's like science right
It's
there.
like science.
So this company was touting their storage array, and they were saying like X many transactions per second. It's the fastest ever.
Yeah.
And then I actually read the environment in which it was tested. And the environment in which it was tested, the machine that they had was enormous, not just in CPUs, but also like it had a stupid amount of memory on the machine. And so I'm like, if we're doing database workloads, we're doing disk IOs, I know that the standard way that Linux and Unix tended to do those workloads was to cache a bunch of stuff in RAM.
Right.
So that it wouldn't like slow down the workload to retrieve the same data or to write the same data that it had already written. And so as I'm like reading the environment details, I'm like, I don't think this claim of however many transactions per second are actually legitimate, because the amount of the sheer volume of memory they had on their test machine, like, is it actually touching the storage array, or is it all just like going in and out of RAM? So yeah, like things like that. Thankfully, one, a lot of manufacturers don't do a ton of benchmarking, and when they do benchmarking these days, they tend to have a much more sane style where it can be reproducible in like customer environments or a standard configuration that they sell, versus like, oh yeah, we did this super highly optimized thing for the purpose of running the benchmark, but you can't actually buy that as a customer.
It's all about getting the numbers though, right? That's the important thing.
Well, and that's what it turned into. It had turned into this like ridiculous thing of like just getting the numbers. And so I think our approach to benchmarking today is much more healthy, where typically we will have a reproducible description of how one can do the same thing that we did to generate the results that we generated. And when you're doing your own benchmarking, that's also something to note. Like, what was the environment in which this was run? So that if later on, like you're Nate, and you're like, oh, what's my maximum throughput? I should look at the benchmark. Well, if you at some point changed your number of cores allocated to this machine, that could potentially invalidate your benchmark data, right? Because now it's not the same as it was when you created it initially.
Or you've added another disk to your SCSI array or something.
Yeah, or up to the cloud instance to include way more memory.
Right, right. Of course, it'll look better on the benchmarks now than it did on day one, because on day one, it was a different physical deployment.
Right. But yeah, like that's the big thing, is you want to always be consistent. You want to always be reproducible, and you always want to be aware that you're comparing two like things in some way when you're doing comparisons, so that you can then understand how things change over time.
I guess it's more about be aware of what it is that you know is different that you're testing for, right?
And I just saw Shantanu said on cloud, you need to create dedicated host VMs to avoid noisy neighbors. So that's one approach. You could try to like get specific hypervisor tenancy. But the other alternative is you could just do more runs, right? And then if you have a noisy neighbor where somebody else is consuming resources from the hypervisor, that ends up being an outlier that you eliminate from your benchmark results. So, so there's,
to be honest, if you're benchmarking to see how your workload is going to run on that cloud provider, you're going to want to deploy it in the same way that you would cost effectively deploy it for production, right? If you isolate that machine and it's not in a shared environment and you get a good benchmark result and you move your stuff to it, but that was too expensive to run for production and you put it in a shared environment, now you're going to get different benchmark data. You won't have accounted for the noisy neighbors.
Yeah. And that may actually be another thing that you would want to know, right? If you have this cluster of data that's different than your main pile of data, how many things are in that cluster, right? How many times did you experience something where it wasn't the result that you were expecting or wasn't similar to the other results? Because that's going to affect your workload too. And now you kind of have a magnitude of how impactful that was to your workload.
Right. And there's a lot of unknowns in a cloud provider or any shared environment, really. Just not just from a noisy neighbor perspective, but even the network throughput, or if you're using cloud-backed storage, right? The throughput to that storage array. I worked with one customer. They had Azure has like an NFS-backed storage solution, and they were getting weird throughput problems. And there were so many layers to the puzzle that the customer couldn't troubleshoot it because they didn't have any insight into the infrastructure. We had to work with the Azure team, like the actual folks that work for Microsoft Azure, to get to the bottom of where the bottleneck was. And it took a long time to get all the data and all the pieces and all the layers. So sometimes it's not straightforward. It's just running a tool on your Linux machine.
Right. And that's actually what the RHEL performance engineering team does a lot, is they end up doing that work with, they actually do a bunch of stuff with different cloud providers and will work on engineering things with the cloud provider. They actually feed all of their performance benchmark data into the insights-driven cost optimization tool, because they know what the kind of maximum throughput should be. So they'll actually make suggestions based off of your current performance copilot collected data on changing your instance sizing to match kind of like what they think the maximum throughput can be on boxes, either up or downsizing. So Nate, do you want to talk about some other industry benchmarking folks?
I had a couple other tools listed. We were talking about websites like Phoronix, right? Did you have you had an example there for Phoronix or no?
Yeah, I was just going to pull up the recent Phoronix RHEL 10 stuff.
So Phoronix is nice because they're independent, right? These are not like folks that are paid by a certain hardware vendor to do, or a certain software vendor to do certain tests, right? They just do the tests.
Yeah. And Phoronix, the guy that runs Phoronix, has a long history of doing benchmarking. You see these sports through things like ads on his site.
Yeah.
So that's how the money comes into Phoronix. But so Phoronix actually did a whole bunch of testing between RHEL 9.6 and RHEL 10 on a whole bunch of things in his benchmark suite. And so as we go through and look at stuff like, those are kind of weird. Not just things like Java and Tomcat, how they prepare or how they performed, but encoding, right, which is really a like, if he's talking about frames per second, so it's doing rendering, graphics rendering. And then he even goes into things like compression. That's actually doing a lot of CPU stuff to do the compression of data. And then kernel compilation, right? That's a lot of CPU stuff, compiling a new kernel. And then he goes into individual applications, right? So like Perl, how does Perl run on these two things? How does Blender run, which is actually doing rendering through Blender, which is a CPU,
right?
CPU thing. Database, so doing different random queries to a database. How does it perform? PyBench, which is also a testing suite that's available in extra packages for Enterprise Linux, where you can wrap your Python program, and it'll tell you how well the Python program performed in a variety of things.
Right.
So that's what he's doing here with PyPerformance.
What I like about his results here is not only does he give you the side-by-side comparison of the two that he's comparing, there's also a little bit of an explanation as to what the test is and what success looks like. Which should the number be higher? Should it be lower? Things like that.
Yeah, and I think that's one also worth mentioning. So on the two that I have displayed on the screen, it says more is better, right? So that's how you judge which one is doing better. There was one earlier. Oh, right here, PyPerformance, right, where it said less is better, right? So if you just look at the graph, you're like, oh, RHEL 10, woof. But the reality is
Look at how much worse it did, but it's not worse
Right.
because
It's
lower is
better.
better.
Exactly. Phoronix does a really good job of testing a whole bunch of different things, but also kind of writing it up. And then he produces the graphs because it's easier to consume data graphically and be like, yes, this is better. This is not better. You can kind of see the difference between the lines to know how much better it appears to be, right? Because if there's a big delta, clearly better or worse. If it's a really slight delta, about the same, right? So yeah, that's and so he did the testing for RHEL 9 versus RHEL 10, and really what we're looking at there is one, different version of things, right? So RHEL 10 came with different versions of things like Java or Tomcat by default, different versions of the kernel, which can also mean different versions of the IO subsystem of the kernel, the networking subsystem of the kernel, the memory management subsystem of the kernel. And so you're able to compare those two things to one another and see which one is better or worse. And then if you look at his write-up, right, he runs it on the same boxes. So you're getting the same hardware, but then the actual like operating system and tools provided by the operating system are different, and that's the comparison that's being made. So you don't have to worry about like one having more CPUs than the other or having more memory available than the other.
And apparently you can get the Phoronix test suite through Apple. I didn't test it out, but I ran across that while I was researching for the show today.
Yeah, I haven't looked at the Phoronix test suite through Apple. I did look at another test suite called D-Bench through through Apple, but their D-Bench is a test harness, and so you then have to provide all the benchmarks that it will run under that test harness. So it's not like CIS Bench where you just like ran, oh, test CPU, oh, test
Right.
file.
Do the thing
You
I
actually,
told you to do. Yeah.
yeah, you have to have benchmarks then to put into the test suite that you want it to run
And
with.
it's possible the Phoronix tool is similar. I'm not sure.
Yeah, neither one of us tried it out.
Yeah. So we touched on CIS Bench. There's another tool called FIO, which is I think it's called the Flexible IO tester or Flexible IO. Let me look up here. Yeah. Flexible IO tester, which can test IO to a number of different subsystems within your Linux system. I don't have a demo set up for it, but it's just something to be, something to know about. That's included with RHEL. That one is not. I think that was included in the base repos. You've used Bonnie++ in the past. That's a disk IO test, isn't it?
It is a disk IO test, and back in the day, it would report on things like angular velocity. So it mattered on your disk, like the actual platter, where your file was located, because like parts of the disk spun faster than other parts, or at least had different velocity
Yeah,
than parts of the disk.
because it's literally a spinning platter where the outside is spinning faster than the inside, right?
Right. And so Bonnie++ would not only tell you kind of like the throughput that you were getting to and from your device, but would also report on we call the ZCAV, zone constant angular velocity of the disk. So you can kind of see what regions were faster than other regions.
Good to know. Put all of my data in the fastest parts of the physical disk.
Which is the outside of the platter, right? The higher
Yeah.
number of cylinders. The bad thing is that if you are maybe you put your OS data or something in the low numbered cylinders, now you have to move the disk read write head back and
Right.
forth across that platter to like get in and out of data potentially. So
Right.
there's also like put it in the middle so that your seek time's minimized. Like there's a whole bunch of weird thankfully things we don't have to worry about anymore because we don't
Right. Right.
it doesn't matter.
Doesn't matter anymore. Cool. Yeah, I didn't have much more for today. So I think that's
Yeah.
all about benchmarking, and not as demo heavy as we usually are, but you got a whole bunch of benchmark theory.
The big thing is try to keep it as constant as possible for your testing so you can compare two things that are like to each other.
And know what you're testing and why.
Yeah. If you measure your throughput performance for I/O on really huge files, but then your actual workload is really small files, that's probably not an accurate test to like see what the actual throughput should be like.
Right. Right. Cool. Well, I guess thanks to everyone who's tuned in for today. We had a decent number of viewers. You've all hung in for 45 minutes of us going on and on and on about something as super exciting as benchmarking numbers.
I think it's cool. We actually didn't talk at all about doing like adjustments to your machine through the kernel parameters to like rerun benchmarks to see if different parameters make a difference.
That's true.
So,
I guess if folks are interested in that, let us know. Maybe we'll make another episode about it, about actual tuning instead of just about measuring, but about tuning.
well, we've covered tuning a couple different places
Yeah.
in the past. What we did not do is actually show with data, oh, we twiddled this thing, and now when we run the same thing, it performs better or worse, right? That's
Right.
something we've not done, but maybe we could try that out now that we have CIS Bench as a really easy to use benchmarking tool.
So did you also learn about CIS Bench to prep for this episode? Because that's when I learned about it.
Yeah, we use internally a tool called pbench. And so that's that and some of the wrapping tools that we have. So I mentioned the performance engineering team, they actually have a whole suite of tools that they use for things like spinning up cloud VMs and running the benchmarks and collecting the data and then turning the cloud VMs off, right? So they have all this like command and control software that they use as well to help them get the data, organize the data, and analyze the data.
Shantanu wants us to do an episode on overclocking, like literally switching jumper settings on motherboards to overclock CPUs. I have not done that in 20 years.
Right. I do everything virtually now. So yeah. Jumper settings on my virtual machines is
can you even do that anymore? I don't think you can.
I'm sure you can.
I guess if you're motivated enough, but there certainly aren't jumpers for it anymore. At least not on any motherboard I've worked on recently.
Well, we could do stuff like set different power profiles for the CPU. That would certainly change the clock speed. And that's important because if your clock speed is lower, then your machine is doing less compute work, but it also is consuming less power, right? So things like laptops often have, like when they're unplugged, they throttle down the CPU so that they consume less power and your battery can last longer.
It's like driving under the speed limit to save gas.
Right. But servers and racks and data centers, they don't care about power consumption. They're just going to be like full throttle as fast.
Yeah. Especially if it's somebody else's data center, not me paying the power bill.
Well, ultimately you do pay the power bill through like the costing of your data center, but yeah.
That's what I mean. If it's not my data center, it's their problem.
Don't worry. Amazon charges you for their power.
Oh, absolutely.
It's pricing.
Absolutely. Yeah.
Don't worry about that. Cool. So next week, Nate, I don't think we have a topic picked out for next week, do we?
No, we were kicking around some ideas. We didn't settle on one yet, though. So it'll be great. Something great. Not overclocking.
Not overclocking. Cool. Well, then, thanks, everybody. We will see you next week for another Into the Terminal.
Everybody have a great one.